In this video, I'm going to go over how to get a Storj storage provider set up and running within Hive OS. I've been running various storage providers on the Storj network for several years now. And one of obviously the big benefit with Storj is it is decentralized storage. They're relatively mature. They are pegged to the US dollar. I think it's currently at $4 per terabyte per month. Yep. And then they have bandwidth cost of $7 per terabyte per month. And they're giving out a free 150 gig of usage and bandwidth to basically anybody that uses their network. And they've been doing this for a while. I'm not sure if this is going to be lifetime or not. But I've been taking all of my extra hard drives and basically throwing them on various decentralized storage platforms. And I've noticed that Storj is probably the most consistent with payout, with usage, things along those lines. So today we're going to show you how you can take any of your Hive OS rigs and get Storj up and running on them and providing storage using any hard drives that are attached to your system. So this can be in a Hive OS or in like an Octominer with USB hard drives, any type of internal hard drives. And what I have is I have this storage provider 2, which has all of these hard drives in it. So this is the Quanta 1U chassis I covered in a previous video. So this is what we're going to be using. We're running CPU mining on this right now, so I'm actually going to stop. Gonna unset the flight sheet, and then we're gonna go ahead and connect to it. Just log in. And one of the first things we need to do is there's several steps we have to do. One is we're gonna create basically a logical volume, which will be the equivalent of a software RAID. With all of our hard drives. So this specific unit has 12 hard drives in it. One of them is dedicated to Hive OS and the OS, and then we're going to be basically combining the other 11 together into a logical volume, which we will be providing storage on the Storj network. I'm not going to do that just yet. First, I'm going to head on over to the Storj hosting setup page. And over here at storj.io/node, if you click host a node, here you have to create an auth token. I'm just going to do this real quick. And then once you hit create token, it's going to give you a token. You're going to want to copy that. And then once that's done, just scroll down, and here you're going to see step 2, which is going to say how to generate identity. We're going to go ahead and click on that, and it's going to take you over to the docs. And there's instructions on here for both Linux and Windows. We're going to follow the Linux instructions. But pretty much all we need to do is, first thing we need to do is download the files. So we're just going to hit the copy command here. We're in the Hive shell right now. I'm actually going to connect with PuTTY just because it's easier to copy and paste the commands. If we come over here and just connect to that IP address. Now I'm going to go ahead and paste those commands. This is going to download the identity app that we need to generate the identity. Okay, so step 1 is done there. So that's downloading it. Next is to create it. So we're just going to type identity, create, and storage node. And this is going to take a while to create. Once this gets started up here, it should begin searching. Yep. So it needs to find a difficulty of 36. It's currently at a difficulty of 25. I am running server hardware. These are Xeon E5s, so it may find it fairly quick. So while that's trying to find the necessary difficulty, I'm going to actually duplicate this session, log back in, and we're going to go ahead and set up our logical volume. So in order to do that, you need a tool. You basically need LVM2, which is a tool. If you're unsure if you have it or not, you can just type LVS, and if it says command not found, it gives you what you need to install. So just do apt install LVM2. Yes. This will download the LVM tools. This will give you the ability to manage your physical volumes, your logical volumes, your volume groups, basically everything that kind of builds up and helps you manage the logic volume manager. So that should just take a second to install. Alright, now that that's installed, we're going to do fdisk fdisk and then -L. What this is going to do is this is going to list all of your hard drives. And what you're going to see is we have dev/SDA through, and they may not be in the right order, but we basically have SDA through SDL. However, one of these hard drives is what Hive OS is running on. So I'm going to do a df-h, and this is going to tell me Hive OS is running on SDI. So we know we don't want to touch that one. But for the rest of them, what we want to do is we want to wipe the file system that's on them. And this will basically treat it as a clean drive. Some of these were previous Chia drives that I had pulled off of other machines. So what we're going to do is we're going to do wipe file system -A. We're going to give it the disk. And so now that one is wiped. Then we're going to do B. We're going to do C. D. And the important thing here is to make sure we skip I. If we try to do it, it will block us. It'll tell us it's in use. G, H. We're going to skip I. We're going to go to K. We're going to go to L. Then we're going to do fdisk-L again. Make sure we didn't miss any. It looks like we missed J. So let's go ahead and do J. Okay. So now if we do fdisk-L, we don't have any partitions on any of these disks other than SDI, which is what our operating system is running on. So the next step is to create a physical volume. There we go. Alright, so we've got SDA, then let's do SDB. Alright, then we're going to do SDC, SDD, E, F, G, H. We're going to skip I, do J, let's do K. It looks like K is actually a bad hard drive, so we're going to remove that one. I think it's PV remove. Yeah. Dev SDK. Let me see if this is. Let me go ahead and add L. Oh, SDE, we actually had a problem with. Is SDE the 4 terabyte? Yeah. So SDE, I've had some issues with this drive, so I'm just going to exclude it and probably end up getting rid of it. So let's just see what we've got here. So we're going to do a pv remove dev SDE. Oh, it's actually not even in there. Oh. Yeah, device not found. Okay. That might be why. So we've got A, B, C, D, we skipped E, F, G, H, skipped I, J, we're missing K. Okay. Okay. Now if we do PVS, there we go. So here we can see we've got several drives here. We've got 2 terabyte, 1 terabyte, 1.5 terabyte, 3 terabyte, a couple 500 gigs, another 1 terabyte, and 3 2 terabytes. So the next step is to create a volume group consisting of all of these drives. So we're going to do VG create, and I'm just going to call it data VG for data volume group. And then I'm going to indicate all of the drives. So SDA, SDB, SDC, SDD, SDF, and you don't need this many drives to do this. You can, technically you could do it with 1 drive. I just decided to load up the chassis with a bunch of extra drives I had laying around. So that's where we are. SDK and SDL. Alright, so now our volume group is created. And here we can see it's 14 terabytes. Now what we have to do is we need to create the actual logical volume. So I'm going to do LV create. And this uses extents, which are a little bit different than bytes. And so what I'm going to do, I'm going to create one volume that has all of the free space. So I'm going to do -lv create -l 100% free, all one word. And then we're going to set the name of it to data LV, which is just data logical volume. And then we have to specify the volume group, which is data VG. So we're going to go ahead and create that. And now if we do an LVS, we can see we have a logical volume that's 14 terabytes. Now we need to create the file system on it. So I'm going to do mkfs.ext4, which is the file system we want. And we're going to do dev / now whatever you name the volume group, that's going to be next. And then whatever the logic / the logical volume. Go ahead and do that. And depending on how many drives you do, this may take a minute or two for it to generate the file system. Alright, so our file system's created. Now we need to mount our logical volume to a folder. So first we need to make the folder. I like to just do /data for my logical volume. And then we're going to do mount. And we're going to do /dev /mapper /data vg -data lv. And we're going to map that to the /data folder. And now if we do an ls on the data, we can see we just have lost and found. Now if we do a df-h, we should see that our data, see if we can find it here. Boop, boop, boop. It's right here at the bottom. See our mapper, it's mapped to data, and we have 14 terabytes available. So now what we're going to do is we need to set up, there's a file called ESTC fstab. So just do nano/etc/fstab. And this is where you define anything, any drives that get mounted on boot. And what we're going to do here is we're just going to essentially do the same command we just did. So we're going to do /dev without the mount command, /dev/mapper /data vg-data lv. We're going to map it to the /data folder. And then the file system type is ext4, and do a space. And normally we would just do defaults. And I like to do no fail here. So what that means is if for some reason the volume becomes corrupt or it can't attach it at boot up, your system will still boot up into the operating system. If you don't specify no fail here, then it will actually prevent Hive OS from booting if something goes wrong with one of your drives or the logical volume. So no fail ensures that it always boots into the operating system even if there's a hardware failure. Then we're just going to do Control-X to close, Y to save, hit enter. Now we've got our logical volume set up, and we are still waiting for that identity key to generate. So while that's happening, the next thing we're going to do is we're going to install Docker. Storj runs on Docker, and I don't believe Docker's installed. Nope. So we're going to do an apt install docker.io. Hit yes, and this will take several minutes to install the Docker runtime, and this is needed in order to run Storj. Okay, Docker's installed now, so if we just do docker ps, perfect. We're not going to install Docker yet, or install the node software yet. We just wanted to get Docker up and running. Next thing I'm going to do is we're going to create a folder inside data called storj_data. You can name this whatever you want, or you can just choose to use the root. I like to create a subfolder. This is where all of the storage data is going to be stored. And now we'll just wait until that identity gets generated. Alright, now that our identity is created, the next thing we need to do is we need to authorize it. So to do that, we're going to do identity authorize. And then the name of our identity, which was storage node. And this is where that the authorization code that you would have copied earlier, that should be your email address, colon, and an auth key. You're going to want to copy and paste that in here and run it. So we're going to go ahead and do that real quick off screen. Alright, and so it did that, it ran. Next thing we want to do is we want to confirm that it worked properly. So to do that, we can run these two commands. So the first one, just go ahead and run that. The first one's outputting a 2, and I believe the second one should output a 3. Yep, and as long as you get a 2 and a 3, everything is good. So now the next step that we have to take is we want to copy that identity to our data share. And not the actual data share that we're going to be sharing data from, but actually another folder in there. So we're going to, I don't think we've created one yet. Nope. So we're going to create a directory called storage identity. And then what we're going to do is we're going to copy -r to do recursive. and it's going to be home user .local slash share slash storage slash identity slash storage node. And we're going to copy that into the data storage underscore identity folder. And now if we take a look at that storage identity folder, we should see a storage node folder, which we do, and our identity key is in there. So the next step, now that we've backed that up, is we're going to install the node software. So we're going to go ahead and we already have Docker installed. We can pull down the container with Docker. So we're just going to copy this command, paste it in here, run it. And this is going to download the latest version of the node software. And while that's running, I'm going to go ahead and copy this command, this run command. And what we're going to do is we're going to tweak it a little bit. So I'm just going to copy this in the notepad, and I'm going to remove the line breaks. And what we want to do is we want to change these the identity directory folder and the storage directory. So if you remember, we did slash data slash identity storage underscore identity. And over here, our storage directory was slash data slash storage underscore data. And now we're going to run this. The important thing, make sure you have setup equals true if this is your first run of Storj. We're going to go ahead and paste this. And real quick, before we run that, let me just verify. Storj underscore data, storage underscore identity, we're good there. Go ahead and run this. Let's see here. Okay, couldn't find. Let's go ahead and just yeah. Do data. User. Let's try that again. All right, let's double check our folder. Storage identity. Oh, it needs to be the storage node subfolder. Sorry about that. So when you do this command, you want storage underscore identity slash storage node. Go ahead and run that. All right. So now the setup is done. Let's head back over to the dock. And the next part is to actually run the command that will actually create the container and run it. The first one was just really getting things set up from a system standpoint. So this one, it's going to be similar in that, so the first thing here is our ports. I'm already running 2 storage nodes, so I'm actually going to adjust the ports. Just give me 1 minute while I check my router and see what ports my other nodes are running on. And you will have to forward this port in your router to this system. So keep that in mind. So I am currently using 28967 and 28968. So we're going to change this to 28969. And this, I'm removing the loopback IP just so that I can access it over my network. Normally you would set this to, if you're running on the same system which you have UI access, you could do loopback. If you went on your network, then just remove, you can remove that. The next part, actually those ports I want to leave as is. The way that I handle the port mapping is I handle it in my router. So under address, retromake.net colon 28969, and then I can forward it to the normal internal port. And then here you're gonna replace this with your Ethereum wallet your Ethereum wallet address. Storj is layer 2. Well, it's a token on layer 1 Ethereum. So I'll grab that. And then here you're gonna put your email address in. And then we're gonna take out that. That's all good. Alright, our identity. Remember, we want to include /storage node. And then our data folder. Put here. And then I think everything else should be good. Just gonna remove the line breaks again. Again, this is just something I prefer doing. It is not required by any means. Alright, the next part is to indicate how much storage you want to provide. Their example is 2 terabytes. However, if we do df-h, we've got 14 terabytes. I'm actually going to do LBS. We have 14.1 is the exact amount. So I will be safe sharing 14 terabytes. I generally like to leave like a 50 gigabyte buffer in there, just in case. But in this case, since we have substantial storage, I'm going to do 14 TB under the storage amount. And then really the next thing that we need to do is we just need to plug in our wallet address that we want to receive payouts on, and then also the email address that corresponds with the key that we entered earlier. This is also used if you want to receive emails. If your node goes down for a certain amount of time, the system can send you an email to let you know. Let me grab my wallet. Plug in our email address, and okay. We're going to go ahead and copy this command, run it. I'm going to run it off screen real quick. Alright, and it looks like it ran. So now if we do, if we do docker ps, we can see that it is running We've got looks like the port is shared. Now the one thing I need to do real quick is set up port forwarding in my router. So let me do that real quick. And ideally you want to set up port forwarding first if you can. It makes the startup process a little bit more seamless. Alright, but what we're going to do is we're going to do an external port of, let's see what we set that as. We're going to do an external port of 28969. And we're going to map that to an internal port of 28967. Alright, now if we open up a browser and we go to http://192.168.1.24:14.002. Here we can see our dashboard. Now this is going to say misconfigured, and the reason for that is I didn't have the port forwarded when I first started up the node service. This should autocorrect itself once it detects the port's forwarded. But the node is up and running. Here you can see right now everything shows as 0%. These will flip to 100% as soon as it kind of detects that first scan. But we are up and running. If we just want to verify things are good, then we can take a look at /data/storj data. And here we can see it's generated our orders folder, our storage folder. Let's just see if we have any orders yet. We don't have any active orders yet, right? Our node has just spun up. However, we should start receiving data relatively quick. You can see we've already have had 5 megabytes of bandwidth used. And we're using 5.2 megabytes. So we're already receiving data, which is great. One thing I will mention with Storj is the way the payouts work. You will see a held back amount that is almost like collateral. You can click this link and learn more about it. But essentially your first couple months that you're running your provider, you will see the held amount being a significant amount. It might be 40 to 50%. I forget the exact amount. It drops after a couple months. It will drop to being negligible, and then eventually that does get returned to you. I believe it's after like 12 months, 9 or 12 months. If you click here, they give you all kinds of information here. So months 1 through 3, it's 75% of the revenue is withheld, 25% is paid out. Months 4 through 6, 50s held. Months 7 through 9, 25. And then starting on month 10, you will receive 100% of the revenue. And then on month 16, you'll receive 50% of what was withheld. And then the other 50% is held until you gracefully exit the network. They don't want anybody harshly exiting. They want you to go through basically like the decommission process. If you do that properly, you'll get that 50% back when you're done. But it hasn't been, I haven't noticed it to be too much over time. What you'll be earning is $20 per terabyte in bandwidth for downloads. You'll be earning $10 in terabyte for bandwidth for repairs, and anytime that their system's trying to do audit checks and make sure your data is available. And then $1.50 per terabyte a month for the actual usage. And one thing you will notice is the usage will ramp up pretty quick, right? So we were at 5, we're now at 45 megabytes. This will ramp up within an hour. You'll be seeing, maybe 100 or 200 gigs being used. And then over a span of a month, you'll start to see it really get filled up. But that's really all there is to getting it up and running with a Hive OS rig. The big thing here is make sure you get your router configured for the port forwarding. But that's really it. As far as keeping the system up to date, you can install Watchtower if you don't already have Watchtower installed. And I don't think they do have it. They have it over here. They actually have their own version of Watchtower. We can install that real quick. Oops. So once again, it is a Docker container. And what this does is this just periodically checks their server to see if there's a new version. And if so, it pulls down the new image and reruns the Docker container with the same parameters that you initially ran it with. So once that pulls down the image, okay, and then we can just execute the run command. There we go. Now Watchtower is running, so if we do a docker ps, here you can see that we're running Watchtower and also our storage node. So Watchtower just monitor for that, and it'll automatically update our storage node anytime there's an update pushed out. And that's it for this video. Drop me a comment below. Let me know your thoughts. Let me know if you're running a storage node. The instructions here for setting up the logical volume can also be applied to the Flux Thunder nodes, the new Fractus nodes that they're rolling out. Can be applied to an SC Prime, although I don't recommend it for SC Prime. With SC Prime, they have the capability to just create folders on each individual drive. You don't need to bundle them together. However, for Storj and also for Flux, they need to be one logical volume.